The last force that we're going to discuss is the vertical force. This is your up and down force. This is the force that is kind of constantly in action with us no matter what we're doing in human motion, because it's the force that has to counteract the force of gravity. The force of gravity wants to constantly pull you down at a value that basically just stays constant based on how much you weigh. So the vertical force has to fight this, which means it's going to be the largest force in human motion in every single motion, because it has to fight that force of gravity. It's the force that when we start interacting that ground reaction force with the force of gravity, we can start to get an understanding of how our center of mass starts to displace up and down in any kind of human motion. One really cool basic example is something like going and sitting down in a chair, right? If I were to sit down in a chair, well, my vertical force has to drop a little bit so that gravity can kind of pull me down and my center of mass can shift down into the ground. Now, if I want to do the opposite thing and stand up, now I'm going to have to create more vertical force, and that's going to come from me actually pushing really hard into the ground. Remember Newton's third law, internal forces from my muscles pushing into the ground, creating a vertical force that would shift my center of mass up. Now, this is going to do things like standing up, sitting down in a chair. If I were to do any kind of jumping motion, it's the same type of motion, just an increased magnitude of that vertical force. It is the thing that is really influencing our center of mass in that vertical direction. I think it's incredibly important to understand, too, that the vertical force has to do a couple of things, right? One thing it has to do is initiate the motion in the direction that we're going to go. But it also is very important that that force is going to stop motion. So the second I start to initiate some kind of movement down, before I stop at the bottom, I'm going to see a real increase in that vertical force. My muscles are going to really engage a lot internally so that that ground reaction force can go up. That way I can stop at the bottom of this movement and not just collapse on the ground. This is what the vertical force does to the center of mass in general human motion. This is the vertical force as it relates to general human motion. Now let's take a look at how vertical force works in the golf swing. In the golf swing, when we talk about vertical force, we can keep it pretty simple and look at this pattern of kind of a little bit of an up, down, up occurring in the golf swing. So the first thing we're going to do is we're going to see that as that club and arm start to move up, we're going to see a little bit of an uptick in that center of mass as everything kind of pulls up. And we're going to see a slight movement upward in that vertical ground reaction force. That vertical reaction force has to be bigger than the force of gravity or our weight so that we can initiate a little bit of that movement up. Now, once we get to the top, now what we want to see is a little bit of a dropping. You might see this defined as a little bit of a de-weighting. And what it really actually is it's that as we kind of lessen our interaction with the ground, I'm pushing a little less hard on the ground. Now the force of gravity is going to be bigger than the ground reaction force, and that's going to kind of create a little bit of a drop down as we're kind of creating the end of that transition. Now that we've created that drop down, again, we don't want to just keep dropping down, down, down into the ground. At some point, we've really got to stop that motion and really explode and be able to kind of throw that club, create a lot of club head speed, and a lot of proper angles of attacks and low points with that vertical force. And so that's that last piece of the puzzle. It's a very rapid increase in that vertical ground reaction. We're going to push incredibly hard into the ground with those internal forces, creating a ground reaction force that we hope that jumps up far above body weight so we can stop that motion, start moving upward, and be in a great position to deliver that club through the impact. Now that last piece of that vertical force, we often want to see come from a really powerful lead leg. Seeing a little bit more force coming from that lead leg is a more ideal way to create that ground reaction force so that we can deliver that club in the most powerful, efficient way possible. Now that we've looked generally at how this works in the golf swing, let's jump right into the app and see how to analyze this data of the vertical ground reaction force, how it influences that center of mass, how it relates to the force of gravity, and some of the things that you can start to assess in the performance pie of your golfer to help them get the most out of their use of the vertical ground reaction force.
Tyler, thanks for that great description of vertical force. Now we're back here again in the lab, and we want to go ahead and start to look at vertical force in the Smart2Move app. So again, we're going to just look first at how to look at vertical force in the app, and then we're going to get into our performance pie as we have with all the other forces. So the first thing we want to look at in vertical force is the position of this yellow total vertical force line. And it's a little bit different than our other forces because we're not as concerned with the 0x axis. You'll notice that if we look specifically at the value over here on the right, the total percentage is 100%. And that's what you should see at the address position. Tyler, would you mind just kind of explaining this and how each foot contributes and so on?
Yeah, and I kind of mentioned this in my earlier videos about the idea that the vertical ground reaction force actually has to counteract the force of gravity. And so when someone's just standing there, we have the force of gravity pulling down, and it's going to pull down at a constant value during the entirety of the swing. And that value will be equal to the weight of the person. And so the ground reaction force has to overcome that weight. It has to interact with that weight or that force of gravity. And so when you see this at kind of the start of his address position, you see this 100% value. That means he's basically interacting with the ground from a vertical standpoint at 100% of his body weight, which means you take that up vertical ground reaction force of 100% of body weight, you subtract out the 100% of the weight from the force of gravity, and now you kind of effectively end up with your new zero line. So anytime we see that ground reaction force drop below that 100%, that would be a scenario where the force of gravity is bigger and we're going to see a tendency of motion downward. And anytime we see that yellow value go above 100%, that would be when the ground reaction force vertical is bigger than the force of gravity. And then we would have a tendency of motion upward. So again, it's about thinking about this almost new zero as it relates to ground reaction force vertical and the force of gravity. And so that's something you really have to pay attention to with this force.
Right. So I think it's important if you just kind of look at the start of the swing address and you imagine that yellow line drawing kind of a straight line across the graphs at the below. That's kind of your new zero. Now let's briefly look at just the individual right and left foot here and just get an understanding for how they're contributing to that overall 100%. Do you want to explain that?
Yeah, again, and this is one where it's not like there's going to be this zero of a positive and negative. What the individual lines tell us, the lead or the blue value is going to give us how much they're pushing into the ground. And again, at this address position, he's pushing into the ground with 58% on the lead foot, giving a vertical reaction force of 58. Whereas his trail is pushing into the ground at 42%, meaning he gets a vertical ground reaction force of 42% coming back. So together that creates our 100, and we want to keep an eye on what individual feet are doing because there's some points in the swing where we maybe want one to be a little bit more predominant, but that's a way that we can start to interpret those individual foot graphs.
Yeah, absolutely. Again, I think it's important to just keep focused on the values here on the right. Those, again, are percentages of the person's body mass, and that will really help you understand kind of where they are in relation to that gravity and if we'd expect to see up or downward movement of the center of mass.
For sure.
Now that we've looked at the graphs of vertical force, let's take a look at the other views we have. The first one being our vector view. So in the top right here, you can see the vectors, and this one's a little bit simpler than the other forces because we're really just looking at the length of the vertical vectors, not so much their direction. So anytime we see the total vertical force drop below 100%, we'll see those vertical vectors getting shorter as you do now. And then anytime it gets above 100%, we'll see those vectors grow pretty rapidly and become much longer than they were. We can also see here in the vector view the point of application, which we'll come back to a little bit later when we talk about the performance pie. The last way to look at vertical force in the app is our dashboard, which you can see here in the right side of the dashboard, which shows the total vertical force yellow here in the middle with the individual lead and trail foots on either side, as well as their value or percentage of body mass. So it's just a really simple way to look at vertical force, analyze its changes between swings and so on. Now that we've discussed vertical force and all the ways to talk about it in the app, let's dig into our performance pie as we have with all the other forces. You'll remember that the first piece of our performance pie is sequence and timing. So to look at this, we're going to go back to our kinetic sequence graph, and we're going to look at this third peak here. Vertical force should always peak third or last in the kinetic sequence, and we can see this really simple with the kinetic sequence graph. If we look at these three different lines, you'll see that the vertical force orange peak is the third and the tallest one. This clearly shows that it's peaking last in the kinetic sequence. Now let's talk a little bit about timing, which is very important. If we go back to our vertical force peak here, we always want to see vertical force peaking between lead arm parallel on the downswing to shaft parallel on the downswing. And this is kind of what we call our dynamic range for this. but we often see better players doing it a little bit earlier in that range. Tyler, do you want to explain a little bit about that?
Yeah, again, this is a force that's really important for this acceleration of the club through the impact, right? And so I think, again, thinking about that dynamic speed window of lead arm parallel, club parallel is a great starting point. Again, I've worked with players who are extremely fast, and they might peak this a little bit earlier. And I think what we often see with a lot of amateur golfers is that they tend to peak this force too late, right? You might go to impact with the ball, and that's where they're peaking. And then it becomes very difficult to transfer some of that energy out of the ground, through the body, and out to the club. And so we really want to pay attention to the timing piece of that so that we can utilize the vertical force in effective ways to deliver the club to the ball.
Yeah, absolutely. I mean, I think it's pretty common where we'll see an amateur, a higher handicap golfer who will do that at impact or even before.
Yeah.
So getting them to do that at shaft parallel to the ground is a massive improvement. But you may see a really good golfer or someone that's really fast. They might do that at, lead arm parallel on the downswing or shaft perpendicular, and that's going to work great for them as well.
Yep.
So that's timing. Again, it's really critical that we peak vertical force between lead arm parallel on the downswing and shaft parallel to the ground on the downswing as well. The next piece of our performance pie for vertical force is point of application. And this one is maybe the most important one of all and has a huge impact on all the other pieces of the pie. So again, we're just going to look at the peak of the vertical force, and we're primarily going to focus on the lead foot center of pressure point here, or the blue dot in this right-handed example. Tyler, do you want to talk a little bit about where you want to see that?
Yeah, as that force is coming kind of through the foot, especially in that downswing as we reach those peaks, we want to see that blue dot kind of travel through the ball of the foot. This is a cool example where he gets maybe a little bit out in the toes, but then as he's coming down in and really pushing hard, we see that blue dot travel right through the ball of the foot, and we want to see that because that's the most effective way to create a lot of vertical force. It's the place you just have to push from that place in that vertical direction. As you mentioned, laterally, AP, we can get away with a little bit different ways to push. This is one where we really want to travel through that ball of the foot. And then we often see a lot of golfers as they push hard that even the ball of the foot might come off a little bit, and we'll see that blue dot travel even kind of down through the heel. That can help with some stabilization and kind of help finish off that swing.
During this education, we've been talking a lot about these kind of athletic movements and comparing these forces and movements to other sports. If you think about someone who's dunking a basketball, that's one of the biggest jumps we see in sports. They don't do that by getting back in their heels and jumping, right? They get into the balls of their feet and they jump. And so golf is the exact same thing. We want to see that happening from an athletic position.
I think the other cool thing too, and we've talked about how important the lead leg is for the other forces like the lateral braking and like that AP force as well. This is, again, the proper location to sync up all those things so that the lead leg can do all of the things we need it to do in the downswing.
So it's very critical that we see this point of application specifically for the lead foot in the ball of the lead foot at peak vertical force. The third piece of our performance pie is magnitude. And here again, we're going to look at our threshold value, which you can see this dotted line across the graphs. Our threshold for vertical force is 165% of body mass. And remember, this isn't a PGA Tour average or something that everybody must do, but it's a good starting point. So Tyler, could you just explain that threshold and maybe what you've seen in some of your research?
Yeah, for sure. Again, and it's kind of cool to think about kind of what they need versus what they maybe have the capacity to do, right? And so I'm fortunate that I get to test a lot of high-level amateur players with our golf teams here. And to be honest, Tyler, it's rare that I see someone not approaching 190 or even over 200%. This is especially true for our really fast players. Again, as we work with guys like Jason Zubak, those guys can get in the 230, 250% plus. And so while 165 is I would look at that as like the bare minimum, right? We really want to make sure people are there. But man, that's a great opportunity to really attack someone's efficiency and speed because we know that's a force that's very highly correlated to speed to get them kind of climbing that vertical force even higher than that 165.
Yeah. So in this example, we can see that this person goes quite a bit past the threshold line, all the way up to 219% of their body mass, which is great. We can also really easily see the threshold in our dashboard view here. So if we look again on the right-hand side of the dashboard, specifically at the yellow vertical bar here, we'll see the threshold shown with just this little dashed line. And here again, you can see that this player clearly goes quite a bit above that threshold. If they weren't, we would see a max dot below that threshold, and you'd be able to really quickly analyze and say, hey, they're not quite getting to that 165%. While we're looking at the total magnitude of the vertical force, we want to go ahead and just talk a little bit about lead foot versus trail foot. So what we're going to often see is that the lead foot is contributing a majority of that vertical force. Tyler, do you have anything you want to comment on that?
Yeah, again, I think the graph view is a cool place to see this. You can see it in the dashboard as well. But if we're looking again, blue line is the lead foot for a right-handed golfer. Red line is the trail foot for a right-handed golfer. And as we kind of move back and forth, you can see how each of those individual feet are contributing to that total force. And if we go to his peak, we can see that the lead foot is contributing, 134%. You can see in the 3D vector view that that blue line is taller than the red line, signifying more magnitude. Again, while we might see some players who utilize both legs to kind of push vertically, I think what we tend to see in the better player is that we see that lead kind of dominating that a little bit, right? So this is a player who's 134 versus 85, lead versus trail. And that would be a number that you'd be pretty happy with seeing, kind of satisfied that he's functioning with that lead leg in an effective manner.
Great. So just to summarize, 165% of body mass is our threshold for vertical force. But again, that's a starting point. And we'd like to be able to see just about any golfer be able to reach that, but some will go quite a bit beyond it. And many often will be quite a bit below it when you measure them.
Yeah, for sure.
The fourth piece of our performance pie is the shape of the curve. So we want to go ahead and just take a walk along these graphs and look at what they mean for the player's motion. So here at address, we see 100% of body weight with the contribution from the individual left and right foot. And often those will be a little bit different, but they will add up to the 100%. The next piece of this would be a slight increase in the total vertical force in the early backswing. Tyler, could you explain why that happens or what players do to cause that?
Yeah, you think about it as that tendency of motion, right? As that total vertical force gets just a little bit above zero. It's not that we want a huge shift to the center of mass, but remember, the arms are going to start lifting up, the club's going to start lifting up. And we do see a lot of good players have a little bit of a, again, not standing up, a little bit of a slight shift of their center of mass going up a little bit, which would be signified by a vertical ground reaction force that would get bigger than body weight, right? Yeah. Over that 100%.
You'll often see this done by the player really using their trail foot, and you'll see that here in the graphs by the red line on the bottom kind of growing at the same time that the yellow one does. Another thing to point out in this kind of early backswing into the transition is the distance between the red and the blue lines here are in the graphs. And some players, you'll see that distance really grow quite large. We sometimes call that the bubble. And you'll see some players, it looks a lot more like a basketball. That would be showing someone who has much more load into their trail side versus someone like this player where it's almost parallel to each other. And that's showing, he only gets 56 or 57% into his trail side. Now let's move into this portion where we start to see the total vertical force really drop down. And you'll see it kind of this lowest valley right here. They're down to 63 or 64% of their body weight. Tyler, can you explain what's happening here?
Again, it's all about the tendency of motion, right? So we get a little bit of a shift up of the center of mass. Again, arms are coming up. Again, this is a little bit of that mini squat or a de-weighting or an offloading is something that I've heard people talk a lot about it. In good players, we're going to see a little bit of a drop of that center of mass, and we would see that by that yellow number going below 100%. That would create that tendency of motion of things kind of dropping. And I think this is a cool depiction of it because we know force precedes motion. You kind of see that drop, and then all of a sudden you see kind of the shift down of the body. The arms are starting to drop down a little bit as that center mass shifts down. And that's a really important piece of the puzzle to allow this player to effectively use the positive, large vertical ground reaction force to finish off their swing. I love this view in with our stickman view, where you can actually watch that green dot just shift a little bit down. You can see the arms drop really nicely, and that's that beautiful tendency of motion for things to drop down.
I think there's two quick things to point out with this kind of unweighting, Tyler. One would be a value for that unweighting. Is there a specific amount you like to see?
Yeah, a lot of it's going to depend upon the player, right? I think when you have players who are really vertical players, they like to see those shifts, the squat down and the up. I think getting them in this kind of 65, 75% range, I think is going to be really imperative for them to push really hard. I definitely have seen players be effective at values a little bit higher than that. Again, if we're looking at our really fast, our long drive guys, that number can get down as low as 50%, and that can be effective as well. I think the key is that they have to then have the capacity to generate enough positive vertical force after this to stop that motion down and accelerate the club head through the ball. But there should be some offloading, Tyler. I think I've worked with players where that line just stays flat the entire time. It never drops below the 100%. That's going to make it really, really hard to effectively use the vertical force in the downswing, time it up the correct way, and deliver the club at the right location at the ball.
Yeah, if you want to make that center of mass move up, it needs to move down a little bit first.
Exactly.
So that's kind of that unweighting here. I think the other really important thing to talk about with this unweighting is the timing of when it happens. And you'll see often that unweighting, kind of the max unweighting, really happens right around transition or when the lateral is peaking as well, which we can see here in this graph. It happens almost at the same time. Do you want to add anything there?
Yeah, again, it's just about this idea of force preceding motion, right? We need that offloading to happen around that transition time so that the vertical force can peak in that dynamic speed window of lead arm parallel on the downswing. Again, otherwise everything's just going to be too late.
Absolutely. The next piece in the shape of the curve discussion we want to talk about is just this peak, which we've already mentioned a little bit here. Tyler, do you want to talk a little bit about it in terms of motion and what it means for the golfer?
Yeah, this is playing such a critical role because remember, this golfer has kind of started a little bit of a shift down of their center of mass and their motion. And so remember, forces are about preceding that motion. And so the first thing this kind of build up to the peak is going to do is it's going to stop that downward motion. So if we go to kind of that valley, if that golfer just ends up staying with that really negative number, they're just going to keep falling further and further and further towards the ground, and that's not what we want. So the first thing that force is going to do is it's going to stop that motion going down. Then we're going to be able to kind of build things, and now you're going to see that really powerful shift up through the ball. This is going to help with things like low point controls and attack angles, and hugely correlated to club head speed, right? I've talked about the lead leg lateral force being something that's really important to club head speed. This vertical force and the lead leg contribution at this peak value is incredibly important to accelerating that club head to the ball.
Absolutely. I think the next piece we'll talk about is something we don't see in this capture, but something people will often see, and that's a double peak. There's a good double peak and a bad double peak. Could you maybe explain what that means?
Yeah, I think the good one is the easiest one to start with, and this is in really powerful players where they're pushing so hard into the ground with their internal forces that external vertical ground reaction force just climbs so high that it actually raises the center mass up and actually raises that foot up off the ground. We see this a lot in our long drive players where that foot comes off the ground. And remember, if that foot comes off the ground, it is going to come back down on the ground. And when it comes back down on the ground, you're going to see another kind of abrupt vertical force come up as that foot kind of slams into the ground. That would be what I would call would be a good double peak, right? It's not something that's causing any undue stress on their body. If they can muscularly handle it, it's not going to be an issue for them in terms of injuries in the future. Now, bad double peak would be that scenario of when a golfer finishes his swing, and if you kind of scroll forward as he's finishing his swing, you'll notice that every golfer is going to have to finish by raising the center of mass up, right? The arms are going to come up, the clubs are going to come up, the body is going to kind of come up. You notice the legs starting to straighten. And so sometimes golfers have a tendency to almost stay down too long through the swing, right? They're kind of covering over the ball, keeping things really down through the impact zone. Maybe they've been told like, hey, I've got to keep my head down for 10 seconds after my swing. And what's going to happen is the body's going to fight that. So it knows it has to raise up its center of mass, and so it's going to continue to want to produce vertical force. That double peak can really cause some stresses on the body as you're almost trying to fight that upward motion of your center of mass, and then the legs and ground are trying to push it up, and now you're in a little bit of a battle between those two parts of your body, and that can cause some issues from an injury standpoint for sure.
So good and bad double peak, be sure to keep an eye on those, and when you see them, specifically looking for, is that player's foot, leaving the ground? That's a really good indicator of if it's good or bad.
Exactly.
I think at this point, we've basically walked through the shape of the curve for vertical force and all the important parts we want to talk about. Now we've really covered the entire performance pie for vertical force as well, and let's maybe go look at some drills.
We've just ran through vertical force in the app, how to assess it utilizing the performance pie, and now let's step through just a quick drill progression that we feel like can be really effective for a lot of golfers to help them understand how to utilize vertical force in the golf swing. We often find players who just kind of lack that understanding of how their center of mass should be moving. because it's kind of such a foreign movement. So this is a drill that we worked with our friend Jason, who extensively has done a lot of work at TPI with Dr. Greg Rose. This is a drill I've seen him use extensively, and it's just so effective for golfers to understand this motion. And the reason why is because if you played a sport like basketball or volleyball and you did just a basic jump, when you do that jump, we'd see hands down and then hands up. And that's what we see in a lot of our other sports motions. But it's not how things actually work in the golf swing, because in a golf swing, as our hands go up and we come down, we actually want the reverse to happen, whereas we start pushing really hard with our legs, it's almost going to kind of slingshot the arms and the club down. So legs going up as the arms are going down, and that's a little bit of a unique feel in the golf swing, right?
Yeah.
And so this is what we talk about with a golf jump. So in this scenario, I'll actually have the player kind of get down in a squat position with their arms up, and then I want to jump up as hard as they possibly can with the legs and let the arms follow. So down in that position really hard with the legs, and then the hands follow. That's a really good feel of that golf jump. Again, legs driving the arms, legs going up as the arms are going down. And I might have them do that 4, 5, 6 times just till I can start to see, hey, things are syncing up. And there are different progressions you can do, but one quick way to do it is to, after they do a couple and you see, okay, Tyler, you look like you're getting a really great feel of that. Well, let's give you a club, let's put down a force pedal, and let's just kind of get it linked up with a golf swing, where now we're gonna kind of go to the top of that golf swing and feel that same motion that we just went with, where we're gonna almost create that. And I won't mind you actually seeing you coming off the ground a little bit, right? Really creating that as the arms are coming down. There you go, right? Really seeing those legs push really, really hard in the right location, pushing really hard at the right time, and kind of leading those arms. This is the kind of drill that you're starting to attack a lot of the performance pie when you do a drill like this.
Yeah, I think it's interesting because the golf jump, so often I see it's like a coordination thing.
Yeah.
You tell people to squat down and put their arms up, and they kind of go, wait a second, like how do I do that? Because it's very counterintuitive. And then I think it's really important with this one is to always just feel like you're pushing extra hard from the lead foot.
Yeah.
You know, we talked a lot about that in the vertical video just before this. Super important that, you know, it feels like twice as much of that is coming from that lead foot.
For sure. And now we're looking at point of applications of the vertical force coming from the ball of the foot. We're looking at magnitudes, and again, more magnitudes coming from the lead side. That's great. We get awesome timing because the legs start driving before the arms, as opposed to that player who comes down and then they're like, oh, now let's push. And now we're really accessing a lot of that performance pie with just a quick 2-drill progression that will help your players improve their vertical force. Lots of other great drills we have for golfers to utilize to improve their vertical force. Check out some of those, utilize some of these, and watch your golfers improve that vertical force and improve the motion and the power in their golf swing as well.